No. Way to read my mind, okay? Same variables or constants. Oh.
Yes.
This is a funky word right here, constants. We're talking about math. What is a constant? What is a constant?
No.
Oh.
Nope.
Nope. That's turn.
Hey, what are you doing? Wait, no, but then you would pass
Oh, my land.
A constant, it's a number that stays the same or something.
Good. A number without a variable. Okay. So, my like terms. If I had a 3x and a 4x, could those be combined?
Yes.
Yes, and they would make what?
7x.
7x. Okay. Could 3 and 4x be combined?
No.
Why not?
Because
Why can that not be combined? They don't both have a variable, okay? So, can't be combined. What about 4x and 3y?
no.
Yeah. No.
No.
Construct a viable argument.
They don't have the same.
Good. Don't have the same variable, so they can't be combined because they're not the same variable. Now, what if I had 4x minus 3x? Can I combine these?
Negative 12x.
Ah, there you're wrong.
7x.
No. It'd be 1x. 1.
Shane, go ahead.
1x.
How do you know it's going to be 1x?
You can combine them, but it'd just be like adding a negative to a positive.
So what's really happening with my positives and my negatives?
They're canceling out to make 0.
They're canceling out to make 0 pairs. So this really just equals x. Okay? So I can combine. It doesn't matter if it's positive and negative, or a negative and a negative, or a positive and a positive. Okay? I can combine the terms as long as they have the exact same variable. Okay? So let's go to example number 1. X plus 3x plus 8 equals x plus 14. This looks like kind of a long equation. Can I do anything to make it a little less cluttered?
It says x plus 3, you just make it 3x.
Where it says x plus 3?
3.
Oh, never mind. I thought it was just x plus 3.
But if it was just x plus 3, could I combine those? No, but Simon, it's x plus 3x. Can those be combined? Do they have the same variable?
Yes.
Yeah, so I have an x plus 3 more x's, and then plus 8. Then I have another x and 14. So how many x's do I really have on the left side of my equation? X plus 3x plus 8. How many x's are there really over there? There's really 4 x's. So I can take this x and this x And I can combine them to make one term. Okay, so combine to make one term. And that one term then becomes 4x. So I'm going to rewrite 4x plus 8 equals x plus 14. Now does this look like a problem that we're used to solving?
Yeah.
What's going to be my next step? The first step was we combined. What's my second step?
You subtract the x from the right side.
Okay, so I'm going to get it so that I only have variables on one side. Could I subtract the 4x if I wanted to?
Yeah.
Does it make my problem any easier? No. Does it make it a little easier if I subtract the x and keep positive variables?
Yes.
Yes. Okay, so I'm going to subtract x from here and subtract x from here. So my second step is to get variable only on one side. Subtract an x, subtract an x. Whatever I do to one side, I must do to the other. What do I have left on the left side of my equation now? Wait, no. What do I have on the left side of my equation now? I'm not done. I haven't rewritten my new equation yet. Good. 3x plus 8 equals 14. So now this is like I have a new equation. It's a two-step equation. Okay? What do I do next? I want to try to get that variable by itself, so I need to get everything away from it first. What do I do? Subtract 8, subtract 8. Okay, so then I'm going to undo addition or subtraction. Okay. Take away 8, take away 8. What am I left with now?
Mm-hmm. 2 8s cancel out, right? And then on the other side is a 6. Good.
Now we have a one-step equation. I know that there's 3 x's, and the total of those 3 x's, it equals 6 because my equation is balanced. How do I figure out how much only one of those x's is going to be worth? How do I figure out the value of just one x instead of all 3?
What was that to?
It was to Alex.
Yeah.
Divide by. And 3x divided by 3 is? And 6 divided by 3 is? Now, do you see we've had to go through one step in combining, another step in getting the variable by itself, another step in undoing multiplication or undoing addition and subtraction, and another step in undoing multiplication and division. That's a lot of steps in there, so it would be very easy to make a mistake somewhere in there, yes? So what is really important, especially now? How do I do that?
Oh.
How do I check it? How do I check it? What do I do?
Slot in the 2.
We like to call that substituting.
Yes.
Okay, so we're going to substitute in the 2, so I'm going to do this side first. So wherever there's an x, I'm going to put a 2. 2 plus 3 times 2 plus 8. All right, so 2 plus 3 is 5, 5 times 2 is 10, and 10 plus 8 is 18, right?
No. What about
Order, but I didn't follow the order operations here.
Yeah, because you're doing the inverse operation.
So then what do I do first?
Now you.
What do I do first here when I'm checking? Okay, so 3 times 2 is?
6.
Okay, so now I really have 2 plus 6 plus 8. 2 plus 6 is?
8.
And 8 plus 8 is? 16. And then on the other side I had x plus 14, so 2 plus 14 equals? 16. Are both sides equal? Yes. Then I know I solved my equation correctly.